Hi guys, in this video we're going to talk about how to fill out this foldable on wave parts. So the first thing we're going to do is we're going to do a little bit of labeling and then we'll write down some definitions. And I'm going to try and color code things so it's easy to see. The first thing we're going to do is talk about the types of waves that are shown here. And the first type up here, when those particles are squished close together and far apart, this is called a longitudinal wave. This next wave, where the particles go up and down or back and forth across a spot, this one is called a transverse wave. Whoops, wave. And this down here, where there's just a single disturbance, this one is called a pulse. Now, a pulse could be a transverse or a longitudinal pulse. This pulse happens to be transverse because it looks like part of that transverse wave. So let's look at some parts here. I'm going to pick a color. Let's start with, what is this, like purple, blue? Okay, so I'm going to write the definition over here. This word is rarefaction. It is the part of a longitudinal wave where the particles are far apart. So if I label a rarefaction on my longitudinal wave, it would be this part right here, where those particles are farther apart. This is a rarefaction. This over here is also a rarefaction because it is also spread out there. The other part of a longitudinal wave is called a compression. I'll make that one green. A compression is the part of a longitudinal wave where the particles are close together. So it's the opposite of a rarefaction. So when I look at this, I look for where the things are all bunched up. So this right here, and this thing over here, those are all compressions. Now that's the only parts of a longitudinal wave that we can label. There's one more thing about the longitudinal wave that we'll label here in just a little bit. All right, so for the next one, this transverse wave, we're going to label a couple of different things. I'll start with purple here. The amplitude of a wave is the distance from the original position to the highest point. We don't measure this on a longitudinal wave because we can't really see where the particles were and where they are. But on a transverse wave, if there were no wave, the string would just be this straight line. So the amplitude goes from that line to the highest part. So that right there is the amplitude. Now you could also measure it here from the middle to the lowest part. That would also be the amplitude, but it always goes from the middle. Now, the nice thing about amplitude is it is proportional to energy. So the more energy the wave carries, the bigger the amplitude is, proportional to energy. So another thing that we measure on a wave is called a wavelength. And surprise, surprise, this is the length of a wave. I know you're thinking that's easy. But when we measure it, it's the distance between identical points. Identical, they have to be identical points. You can't measure it from the same height. You couldn't measure it from here to here. That's not identical because here it's going up and here it's going down. They have to be identical. Like if you took a picture and you dragged it, it would match up exactly. So one way that we often measure this is either from crest to crest, which we'll find out what that is in a minute, or trough to trough. Or on a longitudinal wave, we often measure it from compression to compression. So if I were to draw a wavelength on our longitudinal wave up here, it goes from the compression to the next compression. So that right there, the length of that line would be a wavelength. So let's talk about a crest. What's a crest? I'll use this lovely pink color here. A crest is the highest part of a transverse wave. It's like the compression on a longitudinal wave. It kind of goes with that, but it's a transverse wave here. So this top point right here, and this top point right here, and this top point right here, those are all crests. Now the other kind of point, the low point, is called the trough. That is the lowest part of a transverse wave. And that is kind of like the rarefaction. It's not the same thing. It's like. I should put like there, and I should put like over here. It's not the same thing, but it's like it. So this point right here, and this point right here, and this point right here, these are all troughs. Now I forgot to label a wavelength on my transverse wave, but I could go from crest to crest. That would be a wavelength. Or I could go from trough to trough. That would be a wavelength. Now on my pulse, there's not too much to measure here. I don't really have a trough, but I do have a crest. And I can measure a wavelength on a pulse by looking at this part right here. And on this one, I don't really have an identical part. It's kind of starting over, but this is my wavelength here on my pulse. Now this is a foldable, so the way this works is there are two lines here for you to fold these in on. And if we fold it just right, they should meet up in the middle, like this. And you can attach this inside your notebook on a piece of paper, or you can tuck it in that folder that you have. But to remember what it is, you might label it on the outside. This is about wave parts. I hope you enjoyed.